This video is for those of you that are doing a 2-sample t-test. You should have already watched videos for how to collect your samples and made sure that that is completely randomized, whether you did a random sample or whether you ran an experiment and randomized your treatments. But make sure you've watched that video and you have provided an introduction that not only discusses what type of sample you chose and how you assured that it was random, but also just discuss why you chose this question of interest in the first place. Why were you interested in this? What led you to this particular topic? So if you have chosen to compare two data sets and you're looking at averages, this example will run you through how to use MiniTab to complete your report. Now, if you are choosing to use the TI-84, that's fine. However, I'm not going to go through how to set up the graphs here. Your basic histogram would probably be your best option here, and you would have to do that by hand, or you would still have to go enter it into an Excel spreadsheet to make the graph in order to put it into your report. So MiniTab is pretty much a lot like Excel, so I'm just going to stick with that. I do highly encourage you to use MiniTab because it's going to run everything for you. It's going to do all the graphs that you need, and not only that, you can very easily copy that into a Word document straight from MiniTab, and you don't have to recreate everything. So what I've provided is just an example of what type of test this covers. So let's say that I want to know, my question of interest is the sprint time different for males on the track team versus females on the track team? All right, so I'm going to be collecting two different samples myself. This is all data that I have gone out to find, and I've separated that into two different groups. Here are the male times, here are the female times. So in MiniTab, I've already typed this to save some time in the video, but you will first want to define your variables. So under C1 in the gray box here, this is my male group, and under C2 in the gray box, I have my female group. And I have just typed my times 1 through 8 in here. Now, my sample sizes are very small. There's only 8 in each group. That is definitely not what you want for your study. Again, I'm just trying to keep this video short. Your sample sizes should be at least 30 if you want to get pretty good results from this. So what I want to do is I want to summarize statistics from the data that I have collected so I can kind of get an idea of what's going on here. So once I've entered the data into the spreadsheet for step 1, including the headings, step 2 tells me to choose stats at the top of the page, that is here. And then step 3 tells me to choose basic statistics, and step 4 tells me to choose graphical summary. Once you've chosen that, you're going to click in the variable box, which is already blinking for me. Step 5 tells you to highlight all of your variables. So over here on the left, I'm just going to click and drag down until males and females are highlighted in blue. And then choose the select button at the bottom and then click OK. And what that's going to do is it's going to give you two separate reports. The first one that I see is a report for the females only, but it also has a report right behind it for the males. So this report spits out a lot of information. It gives me a histogram for the females, a box and whisker plot. It gives me some confidence interval scales. This part right here gives a lot of information that I know in Martinsville we did not do in class. And if there's something on here that you don't know about, then I would delete that so that if someone asks you questions during your presentation, it's not a question about something you know nothing about. So I'm just going to right click, like Anderson-Darling is something we didn't talk about. Notice that when I clicked on that, it highlighted the whole box. I do not want to delete the whole box, so make sure it's just highlighting Anderson-Darling. And I'm just going to right click and delete that. As well as any like A squared, I'm going to delete. that whole row. I'm also going to delete the p-value. I'm not doing testing yet. I'm just looking at the graph. We talked about mean, standard deviations, variance, skewness, kurtosis. I don't know. I'm going to delete. But just go through anything. We didn't do confidence intervals for median. We just did it for the mean. Make sure you also delete the numbers that were associated with that. And I'm also going to delete the standard deviation confidence interval. You could even actually take confidence interval out completely because we're going to be doing that later anyway. But this is just your summary report. And you can copy this straight to your Word document. That way you don't have to recreate all the stuff. If you right click anywhere in the gray area, you'll notice that it gives you an option to send that graph to Microsoft Word. And it'll pop straight up in your report. You don't have to do the graphs yourself at all. Now, once you, and that didn't put exactly where I want it, but once you've done that, you'll notice after your steps, you see this little double star tip. These are the things that I would expect you to be able to discuss when you're looking at your data set. Oh, and don't forget, you also need to copy your report for mail. You need to do the same thing with your reports mails. You need to include both of those in your report. So, when I'm talking about these things, the first thing you want to talk about is your CUS acronym. And Danville guys, you probably didn't use this, but this is what we use in Martinsville just to remind us what we need to talk about from this histogram. We need to talk about the C, which is the center. Just tell me what your mean is. So for the females, my mean was 5.7. For males, my mean was 6.9. So I can see that the male mean is higher than the female mean for this particular sample. We also need to talk about the U, which is anything unusual. Is there anything that appears to be an outlier? So we may look at these bars that are kind of standing out to themselves. It could be possible, and just kind of mention that. The S is for your spread. You can talk about that in terms of your standard deviation from the mean. And you also need to talk about the final S, which is your shape. Is this graph more symmetric or is this graph more skewed? And it also provides what a normal curve should look like, so you can kind of get an idea of whether you could use that or not. I think for both of these, the top of that curve kind of falls in the tallest part of my graph. Also keep in mind my sample sizes were very, very small, so this is going to be a little more off than what your results should come back as. All right, once you have talked about that, then ask yourself, were the results for both of the groups exactly the same? No, they weren't. I had different results. It looks like my male group had a higher average than my female group. So what I'm going to try to prove is that male sprint times are more than female sprint times. Okay, so to do this, we need to check some conditions for the test. Number one, my samples both have to be random. And that should already be made clear in your introduction because you had to detail your explanation of how you chose your samples. So that should be already taken care of. Step number two, you can assume that these distributions are going to be normal if each one of your samples has at least 30 in it. And you should have assured that, so that's really all you need to do. In a case where you've been approved to do a sample less than that, then you're going to need to put your data into your calculator and go check your normal probability plot. Those instructions are listed here. If that normal probability plot appears to be linear for both data lists, then you can assume that this is normal. But again, if you have sample sizes of 30, you should be good to go without checking that graph. Also, you need to check your 10% independence condition, where your sample size times 10 has to be less than your population for both samples. So if my sample size is I think mine was 13. Yours should be 30 though. So if your sample size is 30 and you multiply it by 10, then that's equal to 300, and that has to be less than the population. So the population in this sense would be all sprint times, and I can probably safely assume that this track team is running more than 300 sprints over all time. So once you've done this in your Word document, just make a statement that all of your conditions have been met. So we're going to continue with the test in the interval. If your conditions are not met, you will need to adjust your sample size until they are. So now that I've run my summary and it appears that male sprint times are higher than female sprint times, I've already copied these over to Word, so I'm just going to X out of those. And I didn't mean to X out of MiniTab, so give me a second. I'm going to pause this because I have to re-enter my data. I don't want to make you. Okay, so now that my data has been typed back in and I've checked all my conditions, I'm going to run some inference for this, okay? So this result that I got, the idea that the male team has a higher sprint time than the female team, is that just random variability? If I did another sample, would that switch and change? Would it be about the same? Or is the difference between these two teams big enough where I can say there's a true difference between the sprint times? And we're going to run a test to determine that. So we're going to go to Stat, which is at the top. We're going to choose Basic Statistics. Step number 2 tells me to choose the 2-sample t-test. In the pull-down tab, we're going to choose each sample has its own column. So that's going to be the second choice. And then in sample 1, we're going to click and we're going to highlight the first variable, which we'll say was my males. That was my C1. So I'm going to highlight males and I'm going to choose select. Then I'm going to click inside the sample 2 box, highlight the females variable, and then choose select. Then you'll go step number 6 to options, and you're going to enter your confidence level, which I did not put on the sheet. That's a little further down actually, which is typically 95%, and then your hypothesized difference. Now what we want to assume out the gate is there's no difference between these two teams. So if there's no difference, that hypothesized difference should be 0. This tells you how to set up your null hypothesis in your report. Now, what I'm going to be trying to prove is that there is a difference. You could use the not equal to, or if your sample is leading you in a particular direction, you can go with that direction. So my particular sample led me to believe that the male times were higher than the female times. So I'm going to go with a greater than alternative, trying to prove that males, my first variable, is greater than my second variable, which is females. All right, number 9, you want to check that we are going to assume equal variance. We're going to click OK, and then we're going to click OK again. And it's going to spit out an entire report. It's going to show you how to set up your hypothesis, and it's going, right here's your test right here. So this is your hypothesis. And it's also going to spit out a p-value. You can right-click beside the 2-sample t-test, and it will send that whole report to Word for you, so you don't have to retype any of that. Now, what I'm interested in from this report is what my hypothesis was and what the p-value is that it's going to spit out. And in this one, the p-value was 0.04. So down here below confidence interval, I've got what you need to discuss about this. So if your p-value is less than 0.05, you're going to reject the null hypothesis. You do have evidence of the alternative. If that p-value is greater than 0.05, we're going to fail to reject the null hypothesis. You do not have evidence of the alternative. Now, this 0.05 is the alpha level that is associated with the confidence level that you are testing at. So because we're testing at a 95% confidence level, then that should be the other 5% that gets you to 100%. Okay. Now, because mine, I'm going to write that under here. Because my p-value came out as 0.04, I'm going to start my conclusion with that. The p-value is equal to 0.04. That is less than the 0.05 alpha level that I am testing out. So I am going to reject the null hypothesis, and that means I do have evidence of the alternative. Now, the alternative that I was trying to prove is that I do have evidence that male sprint times are higher than female sprint times. Okay, so it looks like the girls are outperforming the males since a shorter sprint time is a better performance. Now, I can also use a confidence interval to help support this conclusion. The confidence interval steps, you'll notice, are the exact same steps as your test. The only difference is your hypothesis actually should just say not equal to. We don't see that confidence interval over here yet. So I'm going to go back to stat, back to basic statistics, back to sample T. All of my information should still be in there. I'm just going to go to options and change this alternative to not equal to. And it's going to run that test again. And then you'll see this confidence interval pop up. Now, notice that changed your p-value, and I don't want to use this whole test because that's not the alternative that I wanted to try to prove with. So don't copy this whole thing over. You just want to right-click on top of that confidence interval and just copy that into your report. Okay, now I can use that confidence interval as support for this. Now this one's going to be a little different because it is... So this one provides me with a little glitch. So this one's not going to support it. This one I may want to change how I did my test. I might want to run it with a not equal to, because for this one, if I'm saying that the male times are higher than female sprint times and there is a difference, then 0 should not be in my confidence interval. In this case, 0 is in it, which would mean there is no difference between the times. So because this alpha level, this p-value was so close to this alpha level, when I change it to the not equal to, it changes the result of my test. So this one we might need to run at a not equal to. If we run it at a not equal to, then I would have 0.08 would be greater than 0.05. So I'm going to fail to reject the null hypothesis, which means I would not have evidence that the sprint times are different than the female sprint times. And if I don't have evidence, then they should not be different, and that means 0, which indicates no difference, should be in my confidence interval. So this final sentence is going to give you that structure to write it. We are 95% confident that the interval captures the true difference in sprint times between males and females. And since 0 is in the interval, I do not believe there is a difference. Okay, this one was a little tricky because confidence interval for MiniTab can only be computed with a not equal to alternative, so that greater than alternative kind of messed us up there. But if yours is close, you can play with it. Most tests are different enough where that doesn't affect it. But now you can run this in the calculator. You can run the test in the calculator. The calculator will do some graphing for you too, but it doesn't really show you where the numbers fall. So you would still have to use Excel in some sort of way to do your graphs, or either hand draw them. You can get the test by doing stats and then going over to test. Here's the stat key here. And you choose a 2-sample t-test, number 4. It's going to ask you whether you have data or stat. So first we need to make sure we have our data typed into the calculator. So I'm going to quit out of that. If you go to stat and then choose edit, if you have numbers in there, you want to go up and clear out L1. And in L1, you just want to type in all of your male times. So I'm just going to start with males, type those in real quickly. All right, and then you're going to right arrow over to L2, and this is where you're going to put your female sprint times. Okay, and then you can get your results from stat and then over to test. You would choose 2-sample t-test, which is number 4. You have the data in a list, so you're going to choose data. Your list 1 should be in L1, your list 2 should be in L2. Frequencies are both 1, those should all automatically pop up there. And then U1 is your alternative hypothesis. So we were trying to prove that my group 1 was greater than my group 2. You were going to choose no for pooled, and then you will calculate it. So that gives you the p-value of 0.04. That's the same p-value we had from our MiniTab output. In order to make that, if you did a not equal to test instead, and let me go back to 2-sample t-test, if you changed your alternative to not equal to, just to show that they're different, then your p-value would be 0.08. So your conclusion is going to be very different depending on which test you choose. You can also use the confidence interval. If you go back to stat test, you can scroll down to 2-sample t interval, which is number 0. Your data again is an L1, L2 with frequencies of 1. You'll need to make sure your confidence level says 95% or 0.95. Again, no pool. And then we'll calculate that, and that will give you the same confidence interval we came up with over here. Okay. The only difference is calculator, you just got to transfer all that stuff yourself. You can't just copy and paste it from the calculator. So the last step is, once you've made your conclusions, you have your confidence interval to back you up, you are going to need to watch one final video that's separate from this one that is called Errors and Alpha Level. So please make sure you watch that before you wrap your report up.